Hi guys, welcome back to Nerd Talk. I'm really excited to have you here. So sit back, relax, and get ready for our fourth journey together. This is part 4 of our journey through the formation of the universe and the solar system. In this episode, we dive deeper into the story of the Jupiter, which is the king of planets. Let's recap. In the previous video, we saw about how Mars was formed about 4.5 billion years ago and was once warmer, with volcanoes like Olympus Mons and possible liquid water. It later lost its atmosphere, becoming cold and dry. Missions like Curiosity rover found evidence of past water. The asteroid belt lies between Mars and Jupiter and contains leftover rocky material, including Ceres. Small rocks are called meteoroids, meteors when entering Earth's atmosphere, and meteorites if they reach the ground. Comets are icy bodies from the Kuiper belt that form glowing tails near the sun, like Halley's Comet. Now let's discuss about Jupiter, which is the 5th and largest planet in the solar system. Far beyond Earth, as you move past Mars and the asteroid belt, you encounter Jupiter, the 5th planet from the sun and the largest in the solar system. This massive gas giant is so huge that all the other planets could fit inside it. Because of its dominance, it is often called the king of planets. Formation of Jupiter. Around 4.6 billion years ago, as the solar system was forming, swirling clouds of gas and dust began clumping together. Jupiter formed from this material, gathering most of the leftover gas after the sun formed. It grew so large that it almost became a star, but just missed that chance. Naming Jupiter. Because of its enormous size and dominance, the planet was named after Jupiter, the king of Roman gods. Just like its name, the planet rules over its surroundings with strong gravity and influence. The Great Red Spot, a never-ending storm. As you look closer, Jupiter's surface reveals swirling clouds and colorful bands. The most famous feature is the Great Red Spot, a gigantic storm larger than Earth itself. This storm has been raging for over 300 years, with powerful winds spinning endlessly, making it one of the most dramatic features in the solar system. Jupiter might look majestic, but it's basically one of the most hostile places in the solar system. Since it's a gas giant, it has no solid surface to stand on. As you go deeper into the planet, the pressure increases so much that it would crush anything instantly, while temperatures rise to extreme levels. On top of that, Jupiter is filled with violent storms, strong winds, and intense radiation, making it impossible for life as we know it to survive. So yeah, living on Jupiter itself is a hard no. Europa, a hidden ocean world. One of Jupiter's most fascinating moons, Europa, is considered one of the best places in the solar system to search for life. Surface and structure. Europa looks like a smooth, icy world covered in cracks and lines. Its surface is made mostly of frozen water, and there are very few craters, which suggests it is geologically active and constantly renewing itself. Subsurface ocean. Beneath this thick ice crust lies a massive global ocean of liquid water. Scientists believe this ocean could contain more water than all of Earth's oceans combined. The heat needed to keep this water liquid comes from tidal forces. Jupiter's strong gravity constantly stretches and squeezes Europa, generating internal heat. Despite being so far away, Jupiter's massive size and gravity make it a dominant force in the solar system. Its gravitational pull influences nearby objects, including asteroids and comets, and even helps shape the structure of the solar system itself. With a radius of about 69,911 kilometers, it is roughly 11 times wider than Earth and has more than 2.5 times the mass of all other planets combined. To visualize it, if Earth were the size of a grape, Jupiter would be like a basketball. That's how huge the difference is. Its volume is so large that over 1,300 Earths could fit inside Jupiter.
In terms of distance, Jupiter is located far from the Sun, at an average of about 778 million kilometers, which is about 5.2 astronomical units. 1 AU equals distance between Earth and the Sun. Because of this huge distance, sunlight takes about 43 minutes to reach Jupiter, compared to just 8 minutes for Earth. This also means Jupiter receives much less solar energy, giving it a colder outer atmosphere. Jupiter rotates extremely fast, completing one full spin in just about 10 hours, which makes it the shortest day of any planet in the solar system. This rapid rotation causes the planet to bulge at the equator and leads to strong jet streams that form its distinctive cloud bands. At the same time, because Jupiter is so far from the Sun, it moves more slowly along its orbit. It takes about 12 Earth years to complete one full revolution around the Sun, meaning 1 year on Jupiter is much longer than on Earth. Another important factor is that Jupiter is a gas giant with no solid surface, so it doesn't heat and cool the way Earth's land and oceans do. Instead of seasonal changes, Jupiter's weather is dominated by internal heat and constant atmospheric activity. The planet actually produces more heat than it receives from the Sun, which keeps its atmosphere active all the time. As a result, instead of seasons, Jupiter has continuous, powerful weather systems, strong jet streams, massive storms, and stable cloud bands that stay active year-round. Features like the Great Red Spot don't depend on seasons at all. They just keep going for centuries.
Unlike Earth, Jupiter doesn't really experience noticeable seasons, and the reason comes down to its very small axial tilt. While Earth is tilted by about 23.5 degrees, Jupiter is tilted by only about 3 degrees, meaning it spins almost perfectly upright as it orbits the Sun. Because of this, sunlight is distributed nearly evenly across the planet throughout its 12-year orbit, so there's no big shift like summer or winter.
Jupiter is surrounded by a large system of moons, 95 confirmed moons, making it almost like a mini solar system of its own. These moons vary greatly in size, composition, and features, from small, irregular rocks to massive worlds larger than some planets. The 4 largest and most important moons are called the Galilean moons, discovered by Galileo Galilei in 1610. Io. Io is the most volcanically active body in the entire solar system. It has hundreds of active volcanoes constantly erupting due to strong gravitational forces from Jupiter, which heat its interior. Europa. Europa has a smooth, icy surface and is believed to have a vast ocean beneath its crust. This hidden ocean makes it one of the most promising places to search for extraterrestrial life. Ganymede. Ganymede is the largest moon in the solar system, even bigger than Mercury. It is unique because it has its own magnetic field, something no other moon has. Callisto. Callisto is heavily cratered and ancient, with a surface that has remained mostly unchanged for billions of years. It may also have a subsurface ocean deep below. Beyond these, Jupiter has dozens of smaller moons that are mostly irregular in shape and likely captured asteroids. Together, this complex system of moons behaves like a small planetary system, orbiting a giant central body, Jupiter itself. 95 plus moons of Jupiter. Although Jupiter is not famous for rings like Saturn, it actually has a faint and delicate ring system that was discovered in 1979 by NASA's Voyager 1. These rings are very thin and dark, which makes them difficult to see from Earth. They only become visible when sunlight shines through them from behind. Jupiter's rings are not made of large chunks of ice like Saturn's, but instead consist mostly of tiny dust particles. These particles are believed to come from its small inner moons, such as Metis and Adrastea. When meteoroids hit these moons, they knock off dust, which then spreads out and forms rings around the planet. The ring system has 3 main parts: inner halo ring, thick and cloud-like; main ring, thin and flat; outer gossamer rings, very faint and wide. Unlike Saturn's bright and icy rings, Jupiter's rings are subtle and fragile, constantly being renewed by new dust from impacts. Structure of Jupiter. Jupiter's structure is very different from Earth because it is a gas giant, made mostly of hydrogen and helium, the same elements found in the Sun. Instead of having a solid surface and clear layers like Earth, Jupiter has gradual transitions between layers, making its interior complex and mysterious. Outer layer, gaseous atmosphere. The outermost part is made of thick clouds of gas, mainly hydrogen and helium, along with traces of ammonia, methane, and water vapor. This is the part we see as colorful bands and storms. Middle layer, liquid hydrogen ocean. As we go deeper, the pressure increases so much that hydrogen gas gets compressed into a liquid state. This forms a massive ocean of liquid hydrogen, the largest in the solar system, even though it's not water. Deeper layer, metallic hydrogen. Further inside, the pressure becomes extreme, millions of times stronger than Earth's atmosphere. Here, hydrogen behaves like a liquid metal where electrons move freely. This layer conducts electricity and is responsible for generating Jupiter's powerful magnetic field. Core, the fuzzy center. At the center lies Jupiter's core, but it's not clearly defined. Scientists once thought it was a solid ball of rock and metal, but data from missions like Juno suggest the core is large, diffuse, and partially mixed with surrounding layers, often described as a fuzzy core.
Let's now explore the surface of Jupiter. Jupiter is called a gas giant for a reason. It does not have a solid surface at all. Unlike Earth, where you can stand on land, Jupiter is made of layers of gas that gradually become denser and denser as you go deeper. What we often call its surface is actually just the top of its thick cloud layers, not a real ground. If a spacecraft tried to land on Jupiter, it would first pass through the upper clouds made of ammonia crystals. As it goes deeper, it would enter thicker clouds of water vapor and other gases. The deeper it travels, the more extreme the conditions become. Pressure increases rapidly, temperatures rise sharply, and winds become incredibly violent. Eventually, the pressure would become so intense that it would crush the spacecraft, while the heat would melt and vaporize it. There is no clear boundary where you can say, this is the surface. Instead, Jupiter transitions from gas to liquid to metallic fluid smoothly. Jupiter's atmosphere is one of the most dynamic and powerful in the entire solar system. It is composed mainly of hydrogen and helium, along with small amounts of gases like ammonia, methane, and water vapor. What makes it visually striking are the colorful bands that wrap all the way around the planet. These bands are divided into two types: belts, darker reddish-brown bands; zones, lighter whitish bands. They are not just colors, they represent different temperature and chemical regions in the atmosphere. The belts and zones are separated by extremely strong jet streams, with winds reaching speeds of over 500 kilometers per hour. These winds blow in opposite directions, creating turbulence where they meet, which leads to the formation of storms. One of the most famous storms is the Great Red Spot, a Vishal, long-lasting storm that has been raging for more than 300 years. It is so large that Earth could fit inside it. But it's not the only one. Jupiter is covered with many storms, cyclones, and swirling vortices, especially near its poles. Another unique feature is that Jupiter's atmosphere has multiple cloud layers. Top layer, ammonia ice clouds. Middle layer, ammonium hydrosulfide clouds. Lower layer, water clouds. Unlike Earth, where weather is driven mainly by sunlight, Jupiter generates a lot of its own heat from inside. This internal heat powers its storms, meaning the planet is constantly active, with no real calm periods. Jupiter has the strongest magnetic field of any planet in the solar system, so powerful that it creates a large region around it called the magnetosphere, which is the area where its magnetic force dominates space. This magnetosphere is enormous, stretching up to 1 to 3 million kilometers toward the Sun and forming a long tail that extends far beyond, even reaching towards Saturn's orbit. This powerful magnetic field is generated deep inside Jupiter, where hydrogen exists in a metallic liquid state. As the planet spins rapidly, once every around 10 hours,
This metallic hydrogen moves like an electric dynamo, producing strong electrical currents that create the magnetic field. Inside this magnetosphere, Jupiter traps huge numbers of charged particles, like electrons and ions, many of which come from its volcanic moon Io. These particles get accelerated to extremely high speeds, creating intense radiation belts that are dangerous enough to damage spacecraft. At the poles, this energy produces spectacular auroras, similar to Earth's northern and southern lights, but far more powerful and constant. These glowing lights are caused when charged particles collide with gases in Jupiter's atmosphere, releasing energy as light.
Jupiter is explored because it holds important clues about the origin and evolution of the entire solar system. As the largest planet, it formed early and captured most of the leftover gas and material, making it like a time capsule of the solar system's beginnings. Studying its structure, atmosphere, and powerful magnetic field through missions like Juno helps scientists understand how giant planets form and how planetary systems develop. Jupiter is also important because of its strong gravitational influence, which shapes the motion of asteroids and comets and helps protect inner planets like Earth. In addition, its moons, especially Europa, are among the most promising places to search for life beyond Earth due to the presence of possible subsurface oceans. Exploring Jupiter and its system not only deepens our knowledge of space, but also helps answer big questions about life, planetary formation, and the future of human exploration.
Missions to Jupiter, exploring the giant. The journey to understand Jupiter has taken decades, with multiple spacecraft visiting this giant planet, each adding a new piece to the puzzle. It all began with Pioneer 10 and Pioneer 11 in the early 1970s, the first spacecraft to fly past Jupiter. They gave humanity its first close-up views and revealed the planet's intense radiation and powerful magnetic field. A few years later, Voyager 1 and Voyager 2 made historic flybys in 1979. They discovered active volcanoes on Io, captured detailed images of the Great Red Spot, and revealed new moons. Using Jupiter's gravity, they slingshot deeper into space, continuing their journey beyond the solar system. Then came Galileo, a game changer. It became the first spacecraft to orbit Jupiter and even sent a probe into its atmosphere. Over nearly 8 years, it studied the planet and confirmed a hidden ocean beneath the icy surface of Europa. Other missions, like Cassini-Huygens and New Horizons, also use Jupiter's gravity to speed up their journeys, while capturing valuable data and images along the way. Today, Juno is orbiting Jupiter, diving deep into its atmosphere and magnetic field to uncover how the planet formed. Looking ahead, missions like Europa Clipper aim to explore Europa in detail, searching for conditions that could support life. To be continued in Part 5. Thanks a lot for watching the video. If you're liking the video, please do subscribe, like, and share with your loved ones.